Hi everyone. So I'm going to chat about Kafka Connect. So the talk is connecting the dots, administering Kafka Connect specifically. So first off, introduction to me. My name's Stanley. I'm a principal software engineer working at Red Hat. So I work on all Kafka related things at Red Hat. I'm also a Java champion, a LinkedIn Learning presenter, and as of October last year, I also wrote a book on Kafka Connect. So if anyone is interested, I have 3 copies. So anyone who asks a question will be first ones. And then if nobody asks a question, it will be the first 3 people who can get up here after this session. And I have signed them for you. So yes, so we're going to talk about Kafka Connect. So who is already familiar with Connect, just so I can kind of tailor, yeah. And are people here using Connect in production? Yeah, a few people planning to use it in production? No? Everyone's either using it or not. Okay, so I'm going to talk about sort of what are the things that you should think about when you're running and administering Kafka Connect. Obviously, I can't cover everything that I talked about in the book. So if you want more details, then do check it out. And I'll give some more info at the end if you want to check it out. But yeah, hopefully this is kind of some key things that you should be aware of. But also I've tried to pick out things that perhaps people don't realize or trip people up often. So hopefully this is helpful. So of course, Kafka Connect is our tool that lets you get data from external systems and into Kafka and then back out to another external system. And one of its key features is you can do this with little or no code written by you. So it's pluggable, you bring different connectors for different external systems, it's scalable, you run those connectors on multiple workers, and then it's also resilient because it stores all of its state in Kafka, but also through running multiple workers, it means if one of them goes down, then you can do failover. And then, so in terms of use cases, the obvious ones are building data pipelines, so collecting data from sources, making it available to be consumed and analyzed. And then interoperability. I've actually seen Connect as a really good way to connect together existing systems that perhaps don't mesh too well together and being able to put Kafka in the middle as kind of a buffer. And then also extending existing systems. So often people will use connectors for connecting database insights. So you can use change data capture, where you basically capture updates from a database and put that into a Kafka topic. And there's specific projects that create all different connectors for different databases. And then the final one is mirroring. So if you've heard of Mirror Maker, that's actually built on top of Kafka Connect. So I don't think everyone put their hand up in terms of knowing about Kafka Connect. So I'm going to do a couple of basics, but it's mostly just so we're all using the same terminology. So as I said, it's a system for flowing data between external systems and Kafka. And you primarily use configuration files, so it's pluggable. But actually what's happening is you've got different connectors. So you use a source connector to build a source pipeline, so that's getting data from the external system and into Kafka. And then sync connectors to build a sync pipeline, so that's syncing data from Kafka and into your external system. So I've used the word connector a few times. There are actually multiple different connector plugins that you use as part of Kafka Connect. Connector is one of them, but there are actually a couple of others. So there's transformations and predicates. So these are used for altering and changing the data as it flows through the pipeline. So you can do things like add fields, remove fields, change fields. And then we also have converters. So converters are used for deserializing and serializing the data as it goes into and out of Kafka. So terminology-wise, it's worth being clear on this. I found a lot when I've been working with clients who are using Kafka Connect, there's some confusion here. So a connector plugin can refer to any of these things, and one of the connector plugins is a connector, just to be extra confusing. And then in terms of the flow of data, if you're building a source pipeline, this is what's actually kind of happening under the covers. So from the external system, we run our source connector, then we run transformations, and then we run a converter. And the reason this is useful to understand is because of the flow of data. So when you come in, your source connector is responsible for talking to the external system, and then it converts it into an internal format within Kafka Connect. And then that's the format that the transformations apply to. and then the converter is going to serialize the data to go to Kafka. So I've often found people using a connector and then coming to me and saying, actually, it's not working, the format is completely wrong, I don't understand what's happened. And it's not the connector, it's actually perhaps somewhere in the converter that they've misconfigured. So it's worth being aware of this flow. And then in the other direction, so sync pipeline, it works exactly the same, but they're swapped round. So you first have the converter, in this case it's deserializing from Kafka, then the transformations, and then the sync connector to the external system. So again, worth kind of thinking about if you're ending up with your external system format not as expected, don't just look at the connector, but look elsewhere in the pipeline as well. Okay, so let's first talk about topology. So if you're deploying Connect, this is kind of the first thing you'll have to decide. So there are two different modes that you can run Connect in. Standalone mode, where you have a single worker with all of your data pipelines flowing through it, or you can run in distributed mode. So in this mode, you have multiple different workers that are part of a cluster, and you run the pipelines on any of the workers. And the benefit of this mode, which is the one that I suggest you use, is that if a single worker goes down, you can automatically have the workload put onto the other workers in the cluster. You can actually run distributed mode as a single worker. So my recommendation would be, in most cases, you should just run distributed mode from the beginning, because you can't migrate across. You'd have to take down your Connect cluster and then bring it back up. The other thing that's worth thinking about in terms of what the difference is in standalone mode, the state is just stored on the file system. In distributed mode, it's stored in Kafka. So this means if your Connect workers go down, your state's safe in Kafka with all of the resiliency that it provides. So again, really distributed mode is where it's at. Yeah?
So are these worker nodes different from grouper nodes?
Yes. Yeah, so I'll talk a little bit about deploying it a bit later, but when you're deploying these workers, you deploy them separately to your Kafka brokers. The lifecycle updates and everything that is completely separate to the Kafka brokers. So you'd have multiple brokers running here. So the other thing I often get asked about around topology for Connect is, should I run with a single cluster for all of my external systems, or should I have a different cluster for each external system? Or do I do sort of somewhere in the middle where I have some of them on one and some on a different one? So the primary benefit of having a single massive Connect cluster with all of your external systems connected is maintainability. You have one cluster that you need to update, that you need to keep track of, one set of metrics that you need to look at, one set of logs. So maintainability-wise, this is a very good option. But there are multiple different reasons why you might want to consider running separate multiple clusters. So the first one of this is around isolation. So Kafka Connect automatically will distribute the workload across the workers in the cluster, but it doesn't have any understanding of the different connectors that are running and the resources that those connectors need. So if you have one connector that's very resource intensive and another one that isn't, Connect wouldn't understand that when it's deciding which connectors to run where. So that can be a really good reason to create separation and have one cluster that has one type of connector and then different cluster for another type. In a similar vein, from security perspective, it can be really good to have multiple different clusters. When you run a connector on a Connect cluster, any of the permissions it needs, you have to grant that across all of the workers. And depending on what access it needs, it might be you want to kind of restrict your Connect cluster that's running those. And then finally, for sort of use case optimization. So this is again linked with the kind of resource usage. Depending on your external system, depending on the connectors that you're running, you might find that actually it makes sense to co-locate some of the connectors on one cluster and then have different ones on a different cluster. Ultimately, it's up to you to kind of decide what works. I know in the past that people have talked about this idea of actually if I'm adding more connectors, it could trigger a rebalance and distributing the workload. That's not something that you need to worry about if you're using the latest version of Kafka, because the latest versions, if you add new connectors, it's not going to cause a full rebalance of all of the connectors that are already running. But these are definitely things you should be thinking about. So once you've decided, okay, I'm running in distributed mode, and you've decided what clusters you want, these are the kind of 4 configurations that you need to make sure you get right. So each of these has to be the same on all of the workers in the same cluster, but different on different clusters. So the group ID is how we identify this worker as part of this group, so this particular cluster, and then each of the topics is for the state. So if you end up with multiple different clusters that have the same topic, you're going to see strange things happening. So make sure these are either identical if they're in the same cluster or separate. Okay, so let's talk about preparing the Kafka Connect environment. So to start Kafka Connect, you use a shell script and a properties file, and then stopping it is as simple as just sending it a kill. And the shell script and the properties and all the files you need to run Connect are part of the Kafka distribution. So these are specifically the things you'll need to gather if you want to start Connect. So you need the libraries in the libs directory that are Connect related. And then you need these 2 shell scripts, so Connect distributed and then the Kafka run class. And then configuration files wise, you need Connect distributed properties. So that is your runtime configuration for your workers. And you'll need however many of them for however many workers. And then for each worker as well, you need the Connect log4j properties for logging. There are example files in the config directory in the Kafka distribution, so I just recommend starting from there and configuring them. And then you also need all of your Connect and worker plugins. So the other thing I want to talk about is once you've then collected all these things and you want to start your worker, you need to actually make the connector plugins available inside your Connect worker. And that can be a little bit confusing for people in terms of the specific structure that they need. So when you're installing plugins, what you do is you configure a plugin path within your worker configuration to say, Connect worker, this is where you need to look for all of your connector plugins to load those jar files. And there are 2 different ways you can package the connector jars so that they're available to Kafka Connect. One is an Uber jar, so that contains the actual connector plugin, whether that's connector, transformation predicate, etc., plus all of its dependencies in one jar. Or you can have a directory that then has all of the libraries in it, so your actual jar, whether it's a connector, and then all of the dependencies. And you can actually mix and match, having some Uber jars and then some directories. But the key thing is what you specify as your plugin path. So the plugin path has to point to a directory that either has Uber jars or directories with just one level of jars underneath. So if we had this path here, opt connect plugins is a perfectly valid plugin path. If you specify opt connect, because there's then another layer higher, you'll find your plugins aren't loading as expected. Once you've enabled the plugin path and you think everything's loaded, you can actually look in the logs in Kafka Connect. It will literally list out every single plugin that it's installing. So that's a really good way to check. But it's just worth being aware of this because I know this has tripped people up. The other thing that people often aren't familiar with in Connect is that alongside connector plugins, there are actually a lot of worker plugins. And these are particularly interesting if you're an administrator of Connect. So there are 3, and I'm going to sort of talk on each of them. So configuration providers, REST extensions, and then the mouthful that is connector client configuration override policies. So we'll start with configuration providers. So a configuration provider is designed for you to allow the people who are configuring connectors to better configure them in a secure way. So I've got an example here. So this is a Debezium connector. So this is one of the ones that does change data capture that I talked about. And we're connecting to MongoDB, so we're providing a password. If you configure it like this with the secret here and pass that to the REST API to start the connector, then anyone who has access to the REST API to see the configuration can see this password. But it also gets logged as well. So even if you lock down access to the REST API, if you look at the logs for Kafka Connect, you'll be able to see it there. The benefit of a configuration provider is it lets you obscure this and fetch this information from a different source. So an example is the file config provider. There is a couple of built-in ones, but as with connector plugins, you can implement your own worker plugin for each of these. So you could write your own configuration provider to get it from wherever makes sense for you. So the way you configure it is you specify an alias. So here it's file. And then for that alias, you provide the class, so file config provider, and this goes in your Connect distributed. So as the administrator who's starting Connect, you would configure this. And then anyone who's running a connector can make use of this. So they again use the alias file, and then these two pieces here, sort of the key and the value, are determined by the specific config provider. So in this case for file, you provide the name of the file and then like a key within the file, but it depends on the config provider. The other thing that's worth being aware of is if you're running the connector, you can also configure the config action reload. So that's a configuration that basically lets you tell Connect what to do if something changes in the configuration provider. So you can either have it do nothing or you can have it restart the connector. So it's worth having a look at that config. So the next one is REST extensions. So this basically lets you extend the REST API for Connect. So you can do things like adding user authorization, applying validation logic. And there's one that comes built in, which is the basic auth security REST extension. And you just configure it using REST extension classes. Again, you can write your own. And then the final one I want to talk about is connector client configuration override policies. So this is a way for you to restrict the way that individual connectors override the client configuration. So Connect is under the covers running producer, consumer, admin clients. And by default, you can override all of them. But you can actually change it to say either I don't want anyone to override it, so I want to lock down exactly how my producers and consumers are working within Connect. Or there's also a default one called principal, which basically means that each of the connectors can override the SASL JARS config, SASL mechanism, and the security protocol. But again, you can write your own. So if you're the person that's running Connect and you want to put a bit more restriction on what the people running the connectors can do, then this is a useful thing to be aware of. So the way it works is if, for example, I've configured to say you can override all of them, then when I'm writing my connector, I can put in some configuration here. So the format of it is the name of the client. So in this case, it's consumer and then .override and then the property as though it was a normal configuration. So next I'll talk about some things to be aware of when managing connectors. So these are the basic ones that you're hopefully familiar with. When you're first getting started, you need to list what connectors there are installed, so the connector plugins that are available to you. These aren't the ones that are actually running. This is what you've made available in the plugin path. And then you can start connectors using this endpoint with some JSON, and then you can list the actual running connectors. But one of the things that you might want to do as an admin is check the status of all of your connectors and tasks. So this is a really good endpoint to be aware of. So if you provide the query parameters expand equals status and expand equals info, this will give you a really good readout of exactly what's going on in your Connect cluster. So that's a really quick way to kind of check what's going on. For those of you who aren't familiar with Connect, this is my explanation of how tasks work. So earlier when I was talking about a connector, a source connector that's running a sync connector, actually under the covers what's happening is you have your connector, which that particular process is just there from a kind of coordination perspective. And that determines how many tasks you should actually run. And the tasks are the ones that actually connect to the external system. So in my original diagram where I said source connector and then transforms converter, that's technically a task that's running there. So those are then obviously distributed across the workers. It's really useful to be aware of the status because the tasks and the connector can fail. And if they do fail, Connect doesn't restart them automatically. So you will have to go in and do that. And you do that using more REST APIs. So we have restart for connector and then restart for a specific task. But this one here is one that's relatively new. and is really useful to be aware of. So you can actually now restart specifically all of the failed connectors and tasks. So before you would have had to check the status and then determine which ones have failed and then just restart the ones you noted have failed. Now you can do it all in one go. So alongside the kind of restarting of connectors in terms of life cycle, the other thing you can do is to pause, stop, and resume a connector. So pause has been around for a while, but actually stop is relatively new. And for both of these, once you've paused or stopped, then you continue by doing a resume. So I'm going to look at what the difference is between these. What have I done with my water? Okay, so for pause, this affects the connectors and the tasks. So if you pause a connector, all of the connectors and the tasks, they still exist. They're still there on the connect cluster. Every time you do a rebalance and things get distributed across the workers, they're still allocated. But there isn't any data flowing through the system at this point. This is really fast to resume because everything's kind of ready to go. As soon as you do resume, the data will flow again. But stop has now been added to the connect API. So if you stop a connector, what will happen is the connectors will get shut down, but the connector is still allocated during a rebalance. So when we determine what needs to be set across the different workers, that connector process will still be allocated. But for those of you who've actually looked at the connect API, the stop method on the connector is actually called. So when you resume, it'll then get start called again. But it is allocated. But all of the tasks are shut down if you do stop, and they're not allocated. This is better from a resource usage perspective. So if you want to just do a quick pause, do something and then continue, then you can keep using pause. But if you want to stop your connectors for an extended period of time, then I definitely recommend looking at the stop method instead, because this, from a resource usage perspective, stops using anything. It's obviously slower to resume though, so there's that trade-off there. And the reason that this was introduced is actually to do with managing offsets in Connect. So hopefully we're all familiar. This is like quite an introductory Kafka slide. But we've got our Kafka topic partition and our offsets. So how we uniquely identify particular records. But specifically how this applies in Connect is when you're running a sync pipeline, Kafka Connect is running a consumer, and so it uses standard Kafka offsets. The same ones you would use if you had a consumer group. So these offsets are stored in a Kafka topic, and it uses them so that if the connector was to go down and come back up, it knows where to carry on in your Kafka topic. But when you're running in the source connector flow, it's the external system that you need to keep track of where you've got to. So for that, we can't use Kafka offsets. Instead, it uses connector determined offsets. So it really depends on the person who's implemented your connector, how they've decided to do offsets. But one of the things that Connect provides is it has a mechanism that connectors can make use of to store their offsets in a Kafka topic still. So for both source connectors and sync connectors, you can have all of your offsets stored in Kafka topics. And until recently, if you wanted to do anything with those, you would have to interact with the topics directly. So for example, you might want to reset a dev cluster by getting rid of all the existing committed offsets, or you might want to just see what offsets your different connectors had got up to, or perhaps skip particular offsets if there's bad records that are causing a problem in your data pipeline. Until recently, you would have had to go in and actually query the topic yourself and perhaps send records to it to change the offsets. But there's now some endpoints that you can use to do it. So the first thing you do is you call stop and stop your connector, and then you can do these. So you can obviously list offsets while the connector's running, but you can alter the offsets and then reset the offsets with delete as well. These were all added in Kafka 3.6. So the listing and the stop was, I think, in Kafka 3.5, but these two were added in 3.6. And the payload, so this is for both the request when you're doing an alter and the response when you're doing a get, looks like this. So for the sync connector, you can see it's specifically Kafka topic partition, Kafka offsets, But for the source connector, it's those connector-defined source partition and source offset. So particularly if you're using a source connector, you do need to do a bit of investigation to understand how is my connector supporting offsets? Is it using Kafka to store the offsets, or is it doing its own mechanism? If it's using its own mechanism, then you can't make use of these endpoints. So then the final thing I want to talk about is planning for failure. Failure does happen. We want to plan for it rather than make it catch us by surprise. So the first one I want to talk about is rolling restarts. So this is kind of to your question earlier about where you run Kafka and Connect. So Connect should be run separately from your Kafka brokers, and the life cycle of your Connect workers should be completely separate from your Kafka brokers. When you're doing a rolling restart, you should restart each of your workers one by one and make sure that all of your connectors are still running afterwards. And there are two things you need to be aware of. One is you should always scale down first. And the reason for this is because if you're running with the default latest settings, if you add an extra worker to your Connect cluster, it will automatically trigger a rebalance because it will think you're scaling up the cluster and it will rebalance all of the connectors across it. However, if you scale down, now that it's using the incremental cooperative rebalance, it will actually wait to do the rebalance for the scheduled rebalance max delay MS. So as long as you configure this so that your worker can come back up again before this times out, then you won't get any rebalances when you're doing a rolling update. So that has the least kind of disruption across the system. So those are the two things to be aware of. If you're managing Connect yourself and you're managing the updates, make sure you always scale down a worker and then bring it up, and then check obviously everything's running, and then etc. And also make sure you've configured this so that the time it takes you to restart a single worker doesn't exceed this. So by default, it's 5 minutes. The next thing to be aware of from a failures perspective is logging. So there's a great endpoint, admin loggers, which lets you list out all of the current logging levels within the Connect workers. This endpoint, actually, you can configure it to be separate to the other REST endpoint, and you can secure it separately. So that's something you might want to consider depending on who has access to your Connect REST API. But it's a really useful endpoint because it means you can dynamically update the logging levels in Connect. So you, for example, like this, you can set everything to debug. Probably wouldn't recommend doing that because that's a lot of logs, but you can set levels for specific classes as well. And then I also just wanted to touch on metrics. There are a lot of Connect metrics, and if you want a full list and which ones you should alert on, which ones you should just monitor, then we did go through it all in the book. But here are some things to consider. So definitely pay attention to the connectors and the task status. As I said before, the connectors and tasks will fail, and if they do fail, they won't automatically restart. So you need to have an alert going for this. Otherwise, you might end up with your data pipelines down for days and you haven't noticed. The second one is definitely have a look at the connection to the Kafka brokers. So you can look at the consumer and the producer metrics for Connect to better understand what's going on. And the final thing is do have a look at the connectors you're running, because an individual connector can also provide specific metrics. They don't all do it, but if they do, this is definitely something you should be looking at from a monitoring perspective. So the final thing I wanted to talk about in terms of failure is dead letter queues, just in case people weren't aware that you could configure this in Connect, because it's a really useful way to easily set up a dead letter queue. So a dead letter queue is designed, so if I've got this existing system, so this is a sync pipeline, and dead letter queues are specifically for sync. So I've got my converter, transforms, and then the sync connector. So in this case, I'm using an Avro converter. So that's assuming that my records in Kafka have been serialized using Avro. If I were to receive a record that wasn't Avro, then my converter would fail. And normally what this would mean is the connector task failed. I have to notice, restart it. But it will just keep hitting that one record. So I would then have to stop it, change the offsets, move past it, continue. But what I can actually do is configure what's called a dead letter queue. So this is basically just a topic in Kafka, and you can configure Connect so that anytime it hits a failure, it will automatically forward the record that had the problem to the dead letter queue, and then it will continue past it. So you can then have an application that's watching this dead letter queue and, for example, reporting an error, but it means that you don't have your pipeline go down, but you can still keep track of what's happened and like which records were the problem. And if you configure a dead letter queue, then it applies to any point in the pipeline. So whether it goes wrong in your converter, transformations, or the actual connector, then they'll all go to the dead letter queue. And this is the sort of configuration. So you basically opt in by specifying a topic name for the dead letter queue. And then you can specify on top of that the replication factor, but it defaults to 3. And you can also specify whether to include a header in the records that go to the dead letter queue with some like additional details. So that was kind of all I had to say in terms of administering Connect. I hope that was useful to give you some pointers of where to go. But if you want to read more, so I have 3 books here, but the top and bottom links take you to the ebooks. You can download that for free. I think it's for like a year, so you have until like October to do that. And then I've also gotten from O'Reilly a link, so this will get you 30 days free access to O'Reilly as well. So feel free to use that as well. And then the final thing I just wanted to promote is Strimzy. So Strimzy is an open source project that focuses on running Kafka on Kubernetes. It's a CNCF incubating project. So do check it out because it does help you with that managing of Connect. So this is one of the primary things that I work on, so it's kind of dear to my heart, but I just think it's an awesome project. So check it out if you're interested. And that's all I had. The final thing I just wanted to point you to is my co-author, Mikkel, so he's not here, but if you go to developersredhat.com, he actually posts every month a digest about what's happened in Kafka. So you might recognize his name. He's the chair of the PMC of Kafka, so he knows what's going on. But it's a really useful digest if you're looking for updates of what's happened. He looks at not just like Kafka itself, but other projects that are using Kafka, what else has kind of been put out there. So do, give that a look as well. Thank you. If anyone has questions. You want to go at the
I
back?
have 2 questions, that's okay.
Yeah.
First is, what scenarios would you run Kafka on Kubernetes? I thought Kafka already is like distributed like Kubernetes work. How does Kubernetes help?
So it really depends on where you're running your infrastructure. So it might be, so I don't know if you're running Kafka on Kubernetes already.
No, I don't know much about Kafka.
Oh, I see. Okay. Yeah. So it's really up to you where you want to run Kafka. So Kafka is distributed by itself. Some of the additional things you get from Kubernetes is help in terms of Kubernetes sits on top of your infrastructure and adds kind of abstractions. So it lets you manage easier things like storage, networking, connecting different applications, that sort of thing. So when people run Kafka and Kafka Connect on Kubernetes, often it's because it's those kind of qualities of Kubernetes that they're looking to make the most of, rather than because there's something specific why Kafka needs Kubernetes, if that makes sense. So you can run Kafka on Kubernetes or not, but you might find there's particular features of Kubernetes that are beneficial to you. And then if you do want to run Kafka or Kafka Connect on Kubernetes, using an operator is really useful, because the role of an operator is, rather than you having to handle, for example, you're running 3 brokers, so you're having to handle each of the kind of pods that are running those brokers and configuring, well, I need these endpoints that my applications can connect to, and I need these specific storage abstractions. All of that's handled by an operator. So you specify, I want a Kafka with 3 brokers, please. And an operator is an application which will basically take that and put in place all of the Kubernetes resources that represent Kafka. I hope that makes sense. I'm kind of trying to judge on your familiarity. Yeah, well, should we?
Does the Kafka Connect operator come in a different license to the main distribution of Kafka?
No, Kafka Connect is part of Kafka, so it's the Apache license. Yeah. Yeah.
I have 2 questions. The first one is about the topologies when we are running Kafka Connect clusters.
Yes.
So do you think it's a good idea to have something similar to like a notebook within, similar to the concept of Kubernetes. So you have different node groups, for example, for Debeziums, and another kind of node group for maybe single S3 kind of connectors.
Yeah, so it's definitely something you can consider. I think it ultimately comes down to that balancing of maintainability versus the kind of isolation, security, and that side of things. For me, in my personal opinion, the big thing that should be weighing in your mind is around the kind of resource usage, because I think that's where it can cause the most unexpected effects on the cluster. Because if you have a particular connector that is very resource intensive, then you could easily, I think, find that you've got one worker that's constantly overwhelmed and then another worker that's kind of sitting a bit idle from as far as you can see, just because Connect doesn't understand the difference between two connectors. It views them as equal. So that can be a really good way to kind of separate them. The other reason that I have seen people running like kind of dedicated ones from a maintainability perspective is in terms of building and maintaining the images. So if you're running in containers, for example, the Debezium project provide images that have the Debezium connectors already in them. So it might be that you only want to maintain a single image with all of your connectors installed, or it might be that depending on the team, so it might be if one team is running these three connectors and then a different team is running a different connector, again, you might not want to have the burden of having to kind of bring together the versions of that connector and the versions of this connector and then running them in one place. So it really is a balancing act between maintainability, but also what isolation and security and other things do I want to kind of handle. Any other questions?
I have a question regarding rebalancing. So when you mentioned that one by one the node will scale down, so the remaining tasks will rebalance to other worker nodes.
Yeah.
What happens with the last worker node when it goes down? All the tasks get full.
So when you're doing a rolling update, you update the workers one by one. So you take one down and then bring it back up again, and then you move on to the next one. And if you've done it with the configuration as I described, what will basically happen is you take down the worker, all of the workload that's on there is currently obviously not running because the worker's not running, but the worker will come back up again and will just continue off where it left off, and the connectors will come back up on that worker. If, however, you've configured your timeout so that the rebalance is triggered before the worker comes back up again, anything that was running on that original worker will get distributed on the rest of them. You shouldn't, if you're doing an update, you shouldn't scale down to 0 and then scale back up to 3, say. You should scale, if you've got 3, you scale down to 2 and then up to 3 and then down to 2, up to 3. You're just bouncing each one in turn. But the key thing is, so particularly if you're running in Kubernetes, if you use a deployment for your Kafka Connect cluster, if you use the default strategy for update, then what it will do is it will normally scale up and add new pods before it removes the old ones. And if you do that with Connect, what you'll find is you're triggering way more rebalances than you need to be triggering. And actually you'll see an interesting behavior where the first pod will come up, it will trigger the rebalance, the other pod will go down, and then the next pod comes up, rebalance. So you'll get 3 rebalances, which you didn't need any of them. But then 5 minutes later, the timeouts will kick in and Connect will go, oh, it's like something's changed, and it will then start doing more rebalances. So yeah, you can use a deployment, but you just have to configure it so that it scales down and then back up again.
So the idea is basically we have to bring tech node tech within 5 minutes.
Yes. And if it's going to take you longer than 5 minutes, then you can extend that timeout to whatever it would take you.
What's the theory behind the toad, or is it a frog?
It's a Pac-Man frog. All of the O'Reilly books have different animals on them. And no, we don't get to pick, but there is a lovely description in the back of the book that tells you about it. And it's actually endangered. It's an Argentine horned frog, also known as a Pac-Man frog. Yeah, you can read in the back of the book. But yeah, we didn't get any choice. We just got told one day, here is your animal. Any other questions? Yeah.
In your diagram, there was a source connector and transformation, and then
Converter.
what does the transformation do generally?
So I had an example of a transformation at some point in my presentation. Let's see if we can go back. Apparently we can't go back. Let me see if I can find it. When was it? I was talking about... trying to remember where it was. Was I talking about overrides? I think I had one somewhere. Maybe I didn't. So a transformation allows you to change the data as it flows through the system. So, for example, there are transformations that let you drop specific fields. So if you had a JSON object, which was your data, that had like a name and then an email address or something, you could drop all of the email addresses, or you could add fields, change fields. It basically lets you customize the flow. So the reason it's beneficial is because the idea is each of the parts have their specific role. So the connector is responsible for talking to the external system. It's an expert of how you integrate with that external system. Whoever wrote the connector should have thought carefully about how to integrate that external system with Kafka, how the flow of data should work in a sort of resilient way. Can we do exactly once, that sort of thing. The converter then is how you want to serialize the data for your applications downstream. So either how the data's arrived in Kafka or how you want it to appear in Kafka. The transformation then lets you have different versions of that. So if I'm flowing data from the same external system, I can use a transformation to easily change what data is flowing through. It's nowhere near as powerful as things like Kafka Streams or Flink in terms of processing and transforming the data. It acts on like one record at a time. But if you're wanting to do small things like mask fields and things like that, it's a really useful way to just filter the data as it goes through the pipeline. Cool. And now I think the last thing is I was going to give out books. So would you like a book? So I think you were the first person who asked the question. I can't remember who else was second. I should have been paying better attention. Do you like a book? And who was third? And if any of you are going to DevBooks UK, then I am also giving away books tomorrow. But you have to have a ticket for DevBooks UK first.
Anything to be aware of if you're running Kafka in KRAFT mode as opposed to Zookeeper mode?
From a Connect perspective, no. It's kind of like, and to be honest, if you're running any Kafka application, you shouldn't care necessarily like what's happening behind the covers.
How deeply responsive.
Yeah, it works just quite happily. It talks to the brokers, so yeah, the Connect controllers are kind of, the Kafka controllers, are separate. Cool. Oh.
Is there a dependency? I mean, is there an advantage of running Kafka with, say, the applications in Java over any other language?
So Kafka Connect is written in Java. So if you're wanting to write a specific connector, then you have to write it in Java. In terms of like, if you're asking me generically, the benefit of writing a Java application as opposed to something in a different library is the fact that every time they release a new version of Kafka, you get a new version of the clients. So I've worked on applications that were written with other clients, for example, using like Go and things like that. And in general, the libraries are great. They kind of keep up, it's fine. But the risk is always there that as soon as the new Kafka version comes out, you get a new Java client. You might have to wait for the Go one or whatever, and they might have, depending on the library, the level of testing might vary. So, for example, the Java ones, you know that they've gone through all of the Kafka community, like system tests and everything. If it's a library that's maintained and used by a lot of people, it's probably got a lot of tests. But if it's just a library that somebody is kind of writing by themselves, it might not be that well tested. So there is a level of risk there.
What's the second best language?
I mean, I'm a Java champion, so Java all the way for me.